Hey there, welcome back to the series where we walk through the LLVM tutorial that is on LLVM.org. This tutorial is the C++ tutorial, the one called My First Language Frontend with LLVM. Thus far, we've made it through 5 chapters and a half. We're going to continue on with chapter 6. Implementing the parser and the generator, the code generator for last time we did the binary operators, and this time we're going to finish off with the unary operators. So excuse me. So a bit of trickery that needs to happen here is previously when we're parsing a binary operator like this, we call this function called parse primary. I'll call that pp. We call parse primary to eat off this one. So when the token cursor is here, we call parse primary, and it'll parse this one. Stick it in, well, I don't know where it remembers the one somewhere, and then it advances the cursor here, and then it'll, I believe, peel off, let me see, it peels off the token, and then and then it'll peel off this operator token, and then advance the cursor here and call parse primary again to get this 2, and then once it has both the 1 and 2, it'll combine them together to make this addition node, right? So previously that's what we had, but now with the addition of unary operators, which previously did not exist, we could have a situation where it's like this: 1 plus not of 2, and also keep in mind we could also have 1 plus not of 2. You could have multiple unary operators stacked up like this. So instead of calling the parse primary, we're going to actually replace those calls with parse unary, just in case that there could be an unary operator associated with this expression, for example. And even for this expression, we're going to call parse unary to parse it, just in case, because we can't know whether this guy has some unary operators on top of it. So basically, when the cursor is here, we're going to call parse unary to parse this guy, and parse unary will know to defer to parse primary. So parse unary will defer to parse primary when it no longer has any unary operators in front of it, when the parse unary has peeled off all of the unary operators. And then the parse binary bit would take that bit and then move over, and then again the parse unary will take that, but since this guy has 2 unary operators, the first call to it will peel off one of them. Move this cursor over here, it call another one of them, move the cursor over here, and then call parse primary because there's 2 unary operators here. I hope that made sense. Let's try to code this. So I was in the middle of writing this parse unary function, and this is the one that's gonna peel off unary operators as long as they exist. And the first thing is it does a check to make sure that to see whether the current token is actually an operator, and that is told by this is ASCII. Oh, and if it's not a parenthesis or a comma. Okay. This looks a little hairy, but because this language is still relatively small, we can still afford to do things like this. Okay, so that's the case where we're not looking at a, so that would be the case where you just have a naked number, I believe. So it's not, oh, I see. If it is a open parenthesis or there's a comma, we're gonna call parse primary to do it. But if it is an ASCII, if the current token is an ASCII, then we're not gonna do this. We're gonna do the rest of it, because that means that's an operator. So the current token is gonna be the actual operator, OPC. Why do we call it OPC? We're gonna advance the token by saying get next token. Okay, we're going to create a new Unary expression node. Move the operand. The operand is going to be the result of, well, of another call to parse Unary. So this parse Unary is actually recursive, and that's to handle the case where you have multiple Unarys in front of. You can have any number of these exclamation points in front of a value. So that's what the recursion is doing for you. And then if this doesn't work, we're going to return a null pointer to signal failure here. And then basically all the places where we called parse primary, we're going to switch it to be parse Unary. Those are all the places. Okay, great. With these two simple changes which we made, we're now able to parse Unary operators and build the AST for them. Next up, we'll need to add parser support for prototypes to parse the Unary operator. Oh, I see. I already did this. I thought they forgot about this in the previous episode. I didn't realize they were first doing binary and then doing Unary. So I just went ahead and added this code here. Here is saying as with, so I already did this. As with binary operators, we name Unary operators with a name that includes the operator character. So Unary and then the character. Okay, now we're gonna write the Codegen for the Unary expression AST. Let's find the class. Okay, let's write the Codegen for it. Okay. Okay, so we're gonna codegen the operand, and if that didn't work, we're gonna return a null pointer, and then we're gonna look up the function, just like what we did with the binary operator. So again, if the operator is exclamation point and it's an unary operator, then we're gonna have a function with that name, and so we're creating this name here, and then using that name to look up a function. And I think if it's not there already, well, it needs to have been registered, yeah. But I think then once you call the function, it'll dynamically generate the AST node in LLVM on the fly when you call this get function. You can look at it. Yeah, it calls the, let me see. Just saying if it already exists, then just return it. But otherwise, we're gonna find a function proto, which is our AST representation, and then codegen this. Yeah, we're gonna codegen it, and then return it. I think Codegen will register it inside the module, if I'm not mistaken. But that's how it works. I just wanted to show you that. Okay, so now we have this guy, and if it didn't work, we're gonna log an error. Otherwise, we're gonna create a call to this function that we found. And this unup is just a name we're using here. Okay, I think it's done. The code is done. Well, not if it has errors in it, then it wouldn't be done, but it does have errors in it. Okay, let's fix some errors. Let's see here. This is saying member initializer opcode does not name a non-static member or base class. Oh, opcode, I cased it differently. Okay, I cased that one wrong. I'm kind of wondering which one is the right one. Okay, let's go to this one, line 254. This one, it doesn't like this one. Use a build. It is builder, not build. And then let's go to this one, 751. It's saying I don't know about this thing called parse Unary. Okay, I'm just gonna move. It's the order of the definition. So if I move it above it, then it'll work. I could also have done a what is this called? I could have moved the signature of the function way up. But in this case, I think I'm just gonna switch the order so that parse Unary is defined before it's actually referenced. That should solve that problem. And then I misspelled std. Here 829, it's fn name, not fun name. Okay, you're close. 847, or are we? this is just called log error. We have more errors. This looks kind of cryptic. No matching constructor for initialization of prototype AST. And it's pointing to a line of code that I don't recognize. This is in this memory library. Oh, but there's code that I do. That is my code here in the instantiation of this function template specialization. So this is on line 911. Excuse me, let me go close the door. Sorry about that. Okay, so it's on this line. I didn't change this line of code. That's interesting. So I wonder what triggered this problem. It could be because I made a modification to prototype AST. Oh. It requires 4 arguments but 2 were provided. Oh, I see. Yeah, yes. So this guy, we're instantiating a prototype AST. Let me split screen here. But we added 2 more arguments to its constructor. I think that's what happened. The is operator and precedence. So we could make a constructor that doesn't have those 2 things, or we could just pass in the like pass this in as false and 0. That would probably do it. Yes, that worked. I wonder what they did in their code listing. So I'm gonna search for this. They didn't change this, which suggests to me they probably had a second constructor that just has 2 parameters. So I think I'm gonna do that. It would make sense. So this is gonna be a constructor overload, I believe. And I'm gonna get rid of these 2 arguments or parameters. Alright, let's see if this compiles. It does. Alright, let's try to run this. Alright, what can you do here? I can define a custom operator. What? I guess I can define the AND operator. So define a binary operator AND with precedence of 40. maybe, and then it takes a x and a y. Expected function name. Uh-oh, we have a sig fault. And we also have unknown Unary operator. Ouch. Let me try to do it all in one line. I'm just gonna return x plus y, maybe. Dang it. Okay. We have a problem. We might have to do some debugging. Oh my god, this Mandelbrot set is super awesome. Okay. So print density. Okay, I'm gonna read this. It is somewhat hard to believe, but with a few simple extensions we've covered in the last chapters, we have grown a real-ish language. With this, we can do a lot of interesting things, including I/O, math, and a bunch of other things. For example, we can now add a nice sequencing operator. So print D is defined to print out the specified value in a new line. Print D, okay, we're using print D. We're gonna define the colon. Oh, I see. Well, let's see if this works, I guess. I have a feeling I'm gonna need to have a separate session debugging this. Okay. Now I'm gonna define a binary operator like this. No, okay. Alright. Ouch. Okay, so I'm gonna need to have a separate debugging session right after this session. So if you're interested in seeing me struggle through this, then I will meet you over there.